Hello and welcome back to another Algebra 1 video. Today we will be starting Chapter 5 with a combined lesson on 5.1, 5.1 extension, and 5.2, which cover the domain and range of a function. First, let's look at our key idea on functions. So a function is a relationship that pairs each input with exactly one output. The domain is the set of all possible input values, and the range is going to be the set of all possible output values. So for an example, we have y equals 3x as our function. For our input, let's say we plug in -2, and notice that -2 is actually going to be plugged in as your x value. So always remember that your inputs are just your x values in a function. As for your outputs, if you were to plug in -2 for your x value, your y value would come out to be -6. So always remember that your outputs are just your y values. For our first example, we're going to find the domain and range of the function represented by the graph. Looking at our graph, we see we have 4 different ordered pairs. Remember that our domain is represented by our x values, and our range is going to be represented by our y values. So first thing I want to do is write the ordered pairs and identify my x and y values, or my inputs and outputs. This ordered pair right here would be -3, -2. The second one would be -1, 0. Our third one would be +1, +2, and our last one would be +3, +4. Now I can go ahead and write those down, and then identify which ones are my inputs and which ones are my outputs. Remember, the inputs are just your x values, and your outputs are just your y values. Now you can identify your domain and range. Remember that your domain is just a set of all your input values, or all your x values, and your range is the set of all your output values, or just a set of all your y values. So for your domain, you would just state all your x values, which is -3, -1, +1, and 3. As for your range, it would be all your y values, which are -2, 0, 2, and 4. Here are another 2 examples, very similar to the last one. We're going to find the domain and range of the function represented by the graph. Again, we want to know our x and y values first, so I'm going to go ahead and write down what these ordered pairs are. This first one is -3, -3. Second one is -1, -3. Third one would be +1, -3. And our last one is +3, -3. Again, remember your domain is all your input values, or just your x values. So I'm going to identify those here. And then your range is just all your output values, or your y values. And notice here that they are all the same, -3. So you just have to write down -3 once. For your domain, you would have all your x values, which are -3, -1, +1, and +3. As for your range, it would just be -3. We can do the same thing for this next example. First, identify all your ordered pairs. This first one would be -2, +4. Our second one would be -1, +2. This is the origin, which is 0, 0. We have +1, +2. And lastly, +2, +4. Again, your domain is all your inputs, or your x values, so I'll identify them right here. As for your range, it would be all your output values, or y values. So now you can go ahead and write that down. Your domain would be -2, -1, 0, 1, and 2. As for your range, it would just be 0, 2, and 4. And looking at our ordered pairs, 2 and 4 do repeat twice, but you just have to write them down once. Next, let's go ahead and look at the definitions of the independent and dependent variable. So the independent variable is going to be the variable that represents input values. And this is because it can be any value in the domain. And because it can be any value in the domain, it basically just means that you can plug in any value into your x value of your function. As for your dependent variable, it's going to be the variable that represents the output values because it depends on the value of the independent variable. Again, the independent variable represents the input, whereas the dependent variable represents the output. You can plug in any number for your x value into your function. However, your y value is going to always depend on the independent variable, which again is your x value. So that's why we call the output values the dependent variable. Here is a problem for us to try. We're given that the function y equals -3x plus 12 gives the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Part A, identify the independent and dependent variables, and part B, the domain is 0, 1, 2, 3, and 4. What is the range? For part A, to identify the independent and dependent variables, we know that the amount of juice remaining in the bottle, which is represented by y, is going to depend on the number of gulps that we take, which is represented by x. So y is the dependent variable and x is the independent variable. And this makes sense because remember that the dependent variable represents the output values, which are your y values, and the independent variable represents the input values, which are your x values. As for part B, we're going to make an input and output table to find the range. Remember that your domains are your x values, so 0, 1, 2, 3, and 4, and we're already given the function y equals -3x plus 12, so all you have to do is plug in your domain values into your x to find y, or your output values, and those output values are going to be your range. To find the range, I'm going to make an input-output table. So remember that the domain is basically just a set of all your input or x values. And because we're given the function y equals -3x plus 12, we can just plug in these domain values into our x values and get our y values, which would be our outputs or the range. So if we were to input 0 for our x value, that would just be 0 plus 12, and your output would be positive 12. Input positive 1, and you would get -3 plus 12, and your output would be 9. Input positive 2, and you would get -6 plus 12, and that would just be 6. As for positive 3, that would give you -9 plus 12, and your output would be 3. And lastly, if you input 4, you would get -12 plus 12, which is just 0. And now that you've plugged in all your input values, you can now state your output values as your range, which would just be 12, 9, 6, 3, and 0. Here is another very similar example for us to try. We're given that the function y equals -4x plus 14 gives the number y of avocados you have left after making x batches of guacamole. For part A, we're going to first identify the independent and dependent variables. Now, because the amount y of avocados remaining will depend on the number x batches of guacamole we make, y is going to be the dependent variable and x is the independent variable. Now this makes sense because remember that your y values represent your outputs, and your outputs are represented by the dependent variable, whereas your x values represent your inputs, which are represented by the independent variable. So you can also identify it by the definition of the independent and dependent variables. As for part B, we're given that the domain is 0, 1, 2, and 3. What is the range? Very similar to the previous problem, I'm just going to make an input-output table. Remember, the domain is just your x values in your function, and you're already given your function right here, y equals negative 4x plus 14. Your range is just going to be your output or your y values. So all you have to do is substitute your domain values as your x and find your y. So if you were to input 0, that would be negative 4 times 0, which is just 0 plus 14, and your output would be 14. Input 1, you would get negative 4 plus 14, and that would be 10. Input 2, you would get negative 4 times 2, which is just negative 8 plus 14, which is 6. And lastly, input 3, and you would get negative 12 plus 14, which is just positive 2. Again, your range is just your set of all the output values or all your y values. So your range would just be 14, 10, 6, and 2. Now we're going to look at the definitions of a function and relation. So a function is a relationship that pairs each input with exactly one output. And a relation is something that pairs inputs and outputs. For the next part of our lesson, we're going to try and determine whether each relation represents a function. And looking at the definition of a function, we know that it pairs each input with exactly one output. So in other words, your x values cannot repeat. So here we're given a relation. We're given 5 different ordered pairs, negative 2, 2, negative 1, 2, 0, 2, 1, 0, and 2, 0. And we're supposed to determine whether each relation is a function. This is pretty simple. Again, a function is something that pairs each input with exactly one output. So just make sure that your x values do not repeat. We have negative 2, negative 1, 0, positive 1, and 2. And since none of them repeat, we know that this relation is a function. For our next example, our inputs and outputs are actually given in a table. So let's just go ahead and focus on our input values and make sure that none of them repeat. We're given negative 2, negative 1, 0, 0, 1, and 2. And looking at all our inputs, we notice that 0 does actually repeat. So because 0 has 2 inputs, 5 and 6, each input does not have exactly one output, so this relation does not represent a function. Here is our next example. Again, we're given a table for both our inputs and outputs. Focusing on our input values, we have negative 9, negative 2, 5, and 12. And we see that 5 and 12 have the same output. However, because each input does have exactly one output value, meaning that none of our input values repeat, this relation does represent a function. Now for this next portion of our lesson, we're going to be using a vertical line test to determine whether a graph represents a function. So a graph represents a function when no vertical line passes through more than one point on the graph. So looking at these two pictures below, we see that this left image represents a function because the vertical line only passes through one point, and this means that each x value or each input has exactly one output or y value. However, on this right image, this graph does not represent a function because we see that the vertical line passes through more than one point on the graph. For our first example, we're going to determine whether each graph represents a function. So we're going to do this by using the vertical line test. So just draw a vertical line through all the points that you see on the graph. So if we draw a vertical line at x equals 1, we see that it only passes through one point. However, if you draw a vertical line through x equals 2, we see that it passes through more than one point. And because it does pass through more than one point, this does not represent a function. As for the second example, you can go ahead and draw vertical lines through all the points on the graph. If you draw it through x equals 1, well, it only passes through one point. And you'll see that if you draw vertical lines all throughout the graph, it continuously only passes through one point. And because of this, our graph does represent a function. Here are a few more examples where we use the vertical line test to determine whether the graph is a function. If we were to draw a line through this graph, we see that our vertical line actually crosses through 2 points at several points in the graph, such as there or here, also here. And because our vertical line does pass through more than one point, it does not represent a function. Here is another example. We can go ahead and draw a line through any point on the graph. And if you keep drawing lines through your entire graph, you'll see that none of the vertical lines pass through more than one point on the graph. And because of this, this graph does represent a function. Here is another graph for us to try, and if you were to draw a vertical line there, you'd see that the line actually passes through more than one point, and this means that this graph does not represent a function. One last example, if you were to draw a vertical line through any of the points on the graph, if you were to draw one right here, you'd see that the line actually passes through more than one point on the graph. So this means that our graph does not represent a function. Now we're going to go over domains. So there are two different types of domains that we'll be learning in Algebra 1, which are discrete and continuous domains. So a discrete domain is a set of input values that consist of only certain numbers in an interval. So for example, we can say integers from 1 to 5, but that would just be 1, 2, 3, 4, and 5. It wouldn't include anything in between, like 1.5 or 3 1/4. However, as for a continuous domain is a set of input values that consists of all numbers in an interval. So if you were to say all numbers from 1 to 5, it would represent everything from 1 to 5 that's in between. So that would include 1.5, 2 1/4, and all those decimal values that rest between 1 and 5. For our very first example, we're still going to be working with functions, except now we're going to be including the discrete and continuous domain. So we're given that the function y equals 15.95x represents the cost y in dollars of X tickets for a museum. So for part A, they want us to graph the function using a domain of 0, 1, 2, 3, and 4. And B, they want us to figure out whether the domain is discrete or continuous and explain. So again, to graph, I'm going to use an input-output table. Again, our domains are our inputs or x values. So we're given the input value of 0, and our function is just y equals 15.95x. So 15.95 times 0 would just be 0. And your ordered pair would just be your x and y values, which in this case is 0, 0. If you were to plug in 1, you would get 1, 15.95. Plug in 2, and you would get 2, 31.9. Plug in 3, and you would get 3, 47.85. And lastly, plug in 4, and you would get 4, 63.8. Now that you found all your ordered pairs with the domain values that you were given, you can go ahead and plot these ordered pairs on a coordinate plane. And because most of your y values are decimals, you can go ahead and just as accurately estimate where they would fall on the graph. And now that you've graphed all your points, you can go ahead and determine whether the domain is discrete or continuous. So remember that a discrete domain is a set of input values that's going to consist of only certain numbers in an interval, whereas a continuous domain is a set of input values that consist of all numbers in an interval. So you really just have to look at the situation that you're given, and because you cannot buy part of a ticket, such as you can't buy like 1/2 of a ticket, the graph is only going to consist of individual points, so your domain is discrete. And the way you represent this on a graph is by leaving the points as is on the graph and not connecting them with a line. Here is another example. We're given that a cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. For part A, we're going to graph the function, and part B, we're going to determine if the domain is discrete or continuous. For part A, we're going to graph the function. However, let's first find what our function is. We know that the number C of calories consumed is a function of the number B of bars eaten, so that just means that the number of calories consumed, C, will equal to 130 times the number of bars eaten, which is B, where C is our dependent variable and B is our independent variable. So now that we found our function, we can go ahead and make an input-output table and find all our ordered pairs. So for our first input, I'm going to input 0, and that would be 130 times 0, which would just be 0, 0. If we input 1, you would get 130 times 1, and that would give you the ordered pair 1, 130. If you input 2, that would be 130 times 2, which is 260, and your ordered pair would be 2, 260. Input 3, and that would be 130 times 3, which would give you 3, 390. And lastly, if you input 4, that would be 130 times 4, and your ordered pair would be 4, 520. And now that you have a good number of ordered pairs to plot on your graph, you can go ahead and draw them on your coordinate plane. And now that we've plotted all our points on a coordinate plane, we can go ahead and determine whether the domain is discrete or continuous. And because you can eat part of a cereal bar, B can be any value greater than or equal to 0, and this means that your domain is continuous. Remember that a continuous domain is a set of input values that consist of all numbers in the interval. And since our domain is continuous, you're going to represent this on the graph by drawing a line through all the points. As always, all information regarding lesson requests, tutoring inquiries, and additional practice will be linked down below in the description box. If you ever have any general questions about the lessons or any of the problems I do in these videos, please feel free to contact me at kaylin.david24@gmail.com. Thank you so much for watching, and I'll see you in the next video.